Okay, the floor is yours. Yeah, you can take it.
Second one. Wonderful. Very good afternoon, ladies and gentlemen, dear esteemed professors. It's a pleasure and honor to be here to present our research on quality assurance and quality control in construction. So, for many years, quality control and quality assurance is a very tedious process, been existing for 100 years. Anything what was built has to be controlled and approved by the site manager, engineer, or architect. If it compliant with the building code, if it compliant with what was designed, and the quality is good. So 11, 12 years ago, things changed. We got devices, mobile devices. And so nowadays, might be seeing on the construction site people using smartphones or tablets to capture the reality and to put all the registration of the events and defects, non-compliances using the digital platforms. So those platforms have been with us already like a decade, and they're doing a very good job of recording events, make timestamps, collecting visual text, sometimes even like voice information. But what they're not good at that is that what stands behind the, let's call it transition, how those events being resolved or remain idle for sometimes. So we found this gap, and we would like to address it using a case study, process mining, and propose to the industry Digital Support Gap Index, DSGI, which is it's a diagnostic score, is from 0 to 100, which will indicate each and every process of QA/QC in terms of its quality. So our methodology consists of 4 pillars. So number 1 is the data pre-processing. We have a lot of events on the construction site. Then we classify this data by certain parameters like activity, scale, risks, actor behavior. 3, we make a scoring using our DSGI index, and then we develop a trigger rules based on this DSGI index, what has to be taken next. So this is the overall methodology. This methodology evolved based on a real construction project, which was quite massive fit-out work in about like two and a half years. The contractor and 18 subcontractors, they used digital platform for quality assurance, quality control, and it resulted in 160,000 recorded events. Based on the classification and grouping them, it was narrowed down to 16,000, and it created 51,000 workflow paths. So overall process of using digital system works like this. So something is found, it's getting open, then it's progress, resolved, feedback, rejected, and closed. So that's like most of the platforms, they operate this way. So that based on this collected data, we created some graphs and also classified those workflow paths into the 5 activity type, like activity type, request type, issue scale, risk classes, effort classes. Based on that, we also figure out so-called like actors. Even though this data was fully anonymized, we didn't know who is doing what, which person stands behind this or that event. And we thought initially it was not good. We should better know the job description of the exact person. But on contrary, based on this data set, we found that so-called like archetype, 7 archetype. The user of the system, they belongs to these 7 groups, from reporter, like opener of this issue, and then like some gatekeeper, and yeah, like 7 of them. As a key takeaway, A2 archetype produced 42% of all the events with only 54% of actors. Then those events has been classified based on the semantic. We analyzed the text description, what was written about this issue, about this event, and what's happened there. And it created also some like 5 categories distributed based on the occurrence. Key insight that 2 major occurrences showed the major attention for the further action is the safety-related cases and handover. Based on that, we proposed a framework for digital support gap index, which consists of 6 elements, 6 components. One of the largest, it has 25 points, which is a closure delay. Then reopen rework is how many counts this issue went back and forth. Then path complexity, actor handoff complexity, semantic criticality, and issue recurrence. So all of this sums up in 100 points. We assume this purely on our expertise, the distribution between them. And after ranking all these events, the paths, 50,000 paths, we found out that there are some critical and highly critical occurrences which require attention. And you will see they're mapped on this graph. So the mean DSGI score falls onto the commissioning and fire safety, which intuitively should sound solid. So in other events which more belongs to interior finishing and interior works, they're not that much critical and they've been resolved fast and efficiently. So our main contribution in this is that we proposing this index, DSGI, to be used in modern digital quality assurance, quality control platforms to assess if any workflows are being stalled or transition is not going well. That index will be used as an indicator to take further action. And there is a gap where the digital platform has its limitation and there is a further step need to be taken. Of course, limitations, it was a single, even like it's a big project, but it's a single project. Then we didn't know the exact job and role profile of the people who did this fill in the events. Yes, that's basically our future work that we now running through the next stage of applying this for further real-life projects and to kind of develop it more robust and sophisticated as a second stage. That's it from my side. Thank you very much for your attention. I will be glad to answer your questions.
Thank you, Vitaly.